All right. Thank you for being here on the first day of DevCon with me. This is probably going to be you're going to have the most energy of the whole week right here, right now. And I appreciate you being here with me for that. My name is Sam Green. I am a founder of Cambrian Network. And today I'm going to be talking about the network effects of verifiable data. Previously, I was a co-founder and CTO at Semiotic Labs. Semiotic is one of the core dev teams in the Graph protocol, and they're focused on verifiable data, AI, and on-chain payments for the Graph. Semiotic also previously incubated Odos.xyz, which is the #1 DEX aggregator in the Ethereum ecosystem. And they incubated Cambrian Network, which I left when we spun it off to lead. Cambrian Network is a blockchain for providing verifiable data to on-chain agents and to smart contracts. And it's built on the Graph. And I'll come back to Cambrian later in the talk, and I'll talk more about how Cambrian interacts with the Graph later. So the focus of this talk is about network effects. And the definition of network effect is that a product has network effects if the value of the product grows when the number of users using that product increases its value. Sorry, I'll just read this. A product has network effects if the value grows as its user base grows or when different types of users join. So there are two types of network effects. There are direct network effects, and direct network effects are when the value of a product grows when just the number of users grow. So Facebook is an example of that. The more of your friends that were on Facebook, the more valuable Facebook became. And the second type is when different types of users join. Those are called indirect network effects. And I'll give an example of indirect network effects in a moment. So Ethereum, actually before I go on, I should say that a product can't just snap its fingers and guarantee that it's going to have network effects. Founders always hope they can build something that will have network effects, but it's no guarantee. It's actually, you have to wait and see, did your product achieve it? Ethereum is a product that for sure achieved network effects or has network effects. So for example, when Uniswap joined Ethereum, it brought in many new users and lots of liquidity to Ethereum, and that increased the value of interacting with Ethereum. And this was proven because of the fact that many new projects came to Ethereum and started actually composing on Uniswap just because of Uniswap's presence. So that is, and that brought more developers and more liquidity. So that's an example of direct network effects. So specifically, if we think of in that DeFi context. I would argue that L2s, the existence of L2s, is an example of indirect network effects for Ethereum. L2s users aren't executing transactions directly on Ethereum, they're executing on the L2s themselves. But the L2s depend on Ethereum for security. And the L2s aren't just like passively using Ethereum, they're also promoting the existence of Ethereum. You may have seen a few weeks ago the ETH is the ticker meme that was going around on Twitter, being tweeted by L2s themselves. And all of these users that I just mentioned are not likely to switch to another L1. So network effects are often sticky. All right, so now I'm going to transition into talking more about how the Graph has network effects. But before I do, I'm going to talk about the Graph itself. So the Graph makes all blockchain data accessible and queryable by providing composable, verifiable infrastructure for decentralized applications. Oh, and if you want these slides, I have a link to the slide deck at the end of the presentation, so there's no need to take any pictures unless you want. At a high level, the Graph organizes blockchain data. So if you look at any blockchain, let's say Ethereum, it's continuously emitting blocks. These blocks have all sorts of information about the smart contracts being executed by the blockchain, and the information is not organized. The blockchains themselves are not responsible for organizing the blockchain data. That's what indexing is for. So the graph takes all that unorganized data and it makes it organized for developers and consumers to use. I didn't appreciate Brian's contradiction to the oil analogy for data, because I'm going to use it. I recently moved to Texas, so I like to bring up that fact every time I can. And I'm going to actually use the oil analogy with the graph. So oil gets turned into many different products. Here are just some of them. These are actually mostly fuels. But actually, petroleum is also the source for many medicines and plastics and thousands of products that we're using every day. Similarly, for the graph, information, there are actually thousands of different information-oriented products that are possible. Within the graph, the blockchain data itself, the unorganized blockchain data, is the raw material. And then indexers in the graph, the indexers are basically like the graph's validators. They do a lot of work, and then they process that raw data, which then gets turned into many different products. At the lowest level of our stack, there's Firehose. So Firehose is the lowest level of the graph's product stack. Then we have substreams and subgraphs, which is somewhat processed data. And at the top, you have basically applications, DApp front ends, Geo, Dapplooker, Token Terminal, Masari, and Tyco are some examples of products that are basically derived from this raw blockchain data. And in general, if you look at the Web 2 data market space, it's gigantic. And there are hundreds or thousands of different data-oriented products. And all of these products actually could be built on the graph. And today, we only have a handful of these products built on the graph, and I expect to see more in the future. So this is I'm going to show the data flow or the data pipeline of our current products, of the graph's current products. At the beginning, you have basically indexers who are running either archive nodes or full nodes. Then there's a piece of software called Graph Node, which is maintained by the graph. And the Graph Node exposes basically queries for GraphQL for data. So Graph Node